Welcome back to another video on visual logic. This one is specifically going to focus on talking about the new user interface that comes with the 2020 version of Active-HDL. It's very similar to the previous version, and most of the videos in this series are using the version that's a few years old. But just wanted to make sure that we just kind of talked about it to relate the new interface to the older interface, so it's not a surprise for if you're a new user for this. This version was published in 2020, is the Active-HDL student version, and I've installed it without putting any of the FPGA library and synthesis tools on it because I don't plan to synthesize it, anything. But just wanted to kind of show you the interface. So under File, you still need to need to create a new design if this is the first time you're doing it. You can start with a workspace, but if you're not going to do a lot of work, you might not want to create that. But usually I'm just going to start with the design, create a new design. And since we don't have any assets or anything, I'll just use the create new design. Again, it just is, as you can see, it's very much similar to the old version, but just it presents a little bit differently. It's reformatted, the fonts have been cleaned up a little bit. So if you go to the next version, the default language, the key thing here is the default language. You want it to be Verliog every time you go through creating anything. We are not going to use any, since we are not building the chip themselves, we don't have any of the vendor libraries to put in here, so you should leave it as non-defined. And then the design name, you can call it anyway, anything you want. I'll call it my first design for now. Just to give it a name. You can put it to whatever directory, much like before. You can browse to find where it is, create new directory, put it where you want. And then you can ask it not to create a separate directory. I think it's a good idea to create a separate directory so things are cleaned up a little bit. So subdirectory structure is always a good thing. And as you can see, the design files will have an ADF extension to them in case you're ever looking for them. And then that's great. That's a good place. Yes, go ahead and put it in. And now I have a design. And then all I have to do to create my code, I add a new file. So in this case, I'll just click on add a new file. And might have put it in my other screen. So oh, sorry, I wasn't double clicking. You have to double click on it. It comes up. Once again, you got to decide what you're doing. We are working on Verliog source code. So there are many different ways of creating through block diagram, state diagram, but let's go ahead and for now, we use a Verliog source code to create it. This is not an existing file. This is a new file, so we click OK. It says, oh, I have to give it a name. So this would be my AND. I'm just going to build an AND gate. That's kind of a simple way of doing it. So I'll do an AND gate. You can name it whatever. Or by the way, you can also use the wizard if you wanted to use the wizard to create it. But I think it's simple enough. You probably want to just type it right in. Say OK. So it'll give you a blank sheet of paper. We know the first thing I have to do, I have to create a framework. First, I have to say what are my inputs coming in. And now, since we are focusing on the interface, I'm not going to make this too complicated. So all we're going to basically do is say, I have a module, and this module I'm calling an AND example. And this AND example is going to have two inputs and one output. And it's better to use more descriptive when you're doing it, but put a semicolon here. So this is where I've created a module. Of course, hopefully you will add comments, but the comments are double slashes. So I can put this as a new file. Once again, the commands, the language has not changed. It's just a user interface of how you enter the language has changed. So this is start of the module. And then I gotta say kind of what the inputs and the outputs are. And in this case, I'm just gonna basically say the inputs are of the type wire. You can drop the wire, it assumes this wire. A comma B, since they're both input, both the same time, I can put them all in the same line. I have one output. And since I'm not gonna use always or any of those constructs, and so I'm gonna call it a wire as well, so it's easier to do the example. And then all I do is assign, basically assigning C to be equal to A and B, and that's the end of that. And the last thing I have to do is end the module, and that's it. Okay. So this is really this is usually where the main body of code comes in, where the actual work gets done, or this function is performed. And then this is where we define the input and the output. Basically, this is the diagram. So that's pretty much all I have to do. The next thing is I can either go under design, find compile all. That would work really well. Or they have this little icon. It's really hard to see them, but you see that right here it says compile all. So everything that you can find, almost everything you can find under the menu, you can also find it in these buttons. The most common ones, you can definitely find it here. For us to either you can do compile all or go under design and just say compile all. Either one of those would work. And down here, this is called the console. It tells you if there was error. Let me create an error. Well, actually, you've seen the error. It just comes out red, tells you what is wrong, and you can hopefully fix it. So that's basically the compilation. So write the code, compile it, and the next thing is we got to test it to see if it works or it doesn't work. And the process there is pretty straightforward. You could go to the simulation, initialize the simulation, or F6 if you want to do that. So we says select the top design unit in the category before first and apply the change. So that basically says what is it that you want. That's fine. My first design is really the workspace I want, but you have to find which one of these things are you trying to simulate. In my case, I'm trying to simulate this function. So I just say okay. And so down here is talking to me and say, hey, your simulation has been implied, automatically figured out what my inputs and outputs are and puts it right here. If it's not showing, you might be here for whatever reason, click on this structure and it shows you what the structure looks like. So that's pretty much it. And then once you have the simulation, you can either go click on the waveform on this icon here, or you can go to simulation, to simulation and find that there. But the easiest one would be just to click on this one. It gives you the waveforms here. And now the last thing you have to do is grab these things, and you can just highlight them, shift arrow, and then just drag them over here and drops so it's going to be left button on your mouse, bring it over here and drop it, and that's pretty much it. And then you can highlight this one, go to the simulation and do it that way, or you can right click here, and that's the easier way. Right click, find the simulator, click on the simulator. And I like to use clock, as I mentioned in the previous videos, because if I use a clock, I can set down to one of them to 10 megahertz. We'll start at and it's usually a good idea to start as a power of 2, because what you want to do, you want every one to be 1 power to less than the other or more than the other. Either way is fine. Maybe we'll start that way. We'll start the first one at 1 megahertz, and we say, okay, override is good. Apply it, and you see it gets bold, because if you don't apply it, then it doesn't take place. And then I can, that's good. Then I could go to B. Notice as soon as I clicked on it, it appeared here. And I can say, okay, I want to use a clock. That one I'm going to do 2 megahertz. And the reason I'm going the powers of 2, what happens then all possible combination of the inputs automatically get created. And I don't have to manually go put values in it or hotkey or other things to do it. So that's the reason I use, for my inputs, I use clock so I can see all the combination. So I'll put that in there. C, I don't have to define because that's an output. So all I have to do, go back here and I say, okay, I want to simulate it for 1 microsecond or 1,000. And there's different ways to run it. This one runs it for that long and stops automatically. If you just run it until you hit the red button, you have to hit the red button and stop it before you can see the stuff. But let me run it this way. Yeah, sure enough, that looks good. It runs it. And I don't know if you can kind of see this here. It's kind of small, but you notice that this clock, something happened here. If you notice, I must have selected the same. So I'm going to go stop the simulation, and I'm going to go back here and see what did I set all these things to. So I'm going to go to this, oops. Right click on this one, go to the simulator. I must be still running something. So let's go there. So no simulation. All right, let's initialize the simulation once more. And let's see if it lets me do that. Okay, simulator is here. Clock is set to 2 megahertz. Yeah, that looks good. Didn't I apply it? Okay, close. And then this one is set to simulator set to, oh, both are set to 2. That's why they were not doing it. Let's set one of them to 1 megahertz. Apply it. Close it. And let's go ahead and run it one more time. Sure. And now you see this is, you see how it's doing it. This is 0, 0, 1, 0, 0, 1. So I have all the combination. And in this case, by the way, if you want to see it cleanly or whatever, you can use this zoom in, zoom out. Right now, it may be too far out, so I'm going to zoom it in so I can kind of see the whole cycle. And that's pretty much it for most of the time until we go to build it in hardware. All we're doing, we're modifying our description through the language, the code, and then we run the simulation to figure out if our design is working or not. I build an AND, and indeed, 0, 0 gives me a 0, 0, 1 gives me a 0, and 1, 0 gives me a 0, and 1, 1 gives me a 1, which is what I meant to do. So that was a quick video giving you kind of a this user interface, and hopefully you'll see it's very similar to the previous videos and the older version of it. Just things have been moved around a little bit. If you use this quite a bit, there are soft keys you can use to do various things, and they usually tell you, for example, to initialize, to end the simulation, you can do Shift F key to initialize it, F6 to initialize the F5 and all of that. And I usually, if you don't, in this, as a beginner, we don't use it enough, but if this becomes your profession, then those soft keys really save you a lot of time. Okay, I've stopped the simulation at this point. We are done with this video. Take care.